Hello guys, today we are going to attempt to solve this problem by using this neat property over here. Um, Before we dive into the problem, let's talk about what this property is really saying. So essentially it's saying that we have a function. It is k to the power of c times x. And what it is stating, let's put that in red. It is saying that the first derivative of this function with respect to x equals c times ln k times k to the power of cx. Now, this derivative looks a lot more complicated than the original. So the derivative looks a lot more complicated than the original function. Let's see how this came about. So when you have a constant, let's say, for example, 3 to the power of x. So if in the exponent of it, there is the differentiable variable, for example, we are now differentiating with respect to x. And if x happens to be in the exponent as an exponent, so you have to use the modified version of the chain rule. And the modified version of the chain rule essentially states that if you want to take the derivative of this function, the derivative would be equivalent, it would be equal of a to the power of u times the derivative of u times ln a. Now this looks a lot more familiar to that. And now let's define what is a and what is u here. So a would be the base that you have. Let's write that in blue. So our base is 3. And the exponent would be u. So, and our x equals u. So let's differentiate this example, and then let's go to the original example. Okay, so the formula is telling us to just write the original function. So a to the power of u, so 3 to the power of x times the differentiation, the derivative of x, which is just a 1, times ln 3. So that is the first derivative of 3 to the power of x, and that looks a lot more similar to this function. Okay, now let's get rid of this. All right, so let's use the same formula now to take the first derivative of fx, of the original function. Okay, so a to the power of u. Okay, so let's assign a to k and u to c times x. And let's continue from there. Okay, so a to the power of u, that would just be k to the power of c times x times the derivative of u. So the derivative of x would just be 1, and c is the constant, so it stays. So it's c times 1. So we can just write c over here times ln a, which in our case, our a is just k. And look, we derived to the same conclusion. Okay, now that we know this, we are ready to start solving an actual problem. Okay, so there is 2 parts to the equation that basically needs to be differentiated. If we are taking the derivative of this equation, first we have to take the derivative of this term, and since they're plus, we have to take the derivative of the second term then. Right. All right, let's start with ln 2x. So ln 2x, what will be the derivative of it? So the derivative of ln is just u prime divided by u, any ln. And what is u? U is whatever that is inside ln. So what does that mean? That means that the derivative, if we call 2x u, then that means that the derivative of u is just 2, and the original function, which is just 2x. So 2 goes by 2, and that equals 1 over x. And you are probably familiar with that. So the derivative of natural log generally is just 1 over x. Of course, if it has a coefficient next to it, then it would be times the coefficient. Okay, so we have derived the first part successfully. Now let's dive into the maybe perhaps more challenging part, which is 5 times e to the power of 5 times x. Okay, so of course there's 2 methods we could use. If you're very familiar with this, you could just go with the chain rule, but let's just use this new formula that we just learned. Okay, so 5 times e to the power of 5x. So this is a multiplication, so we have to also use the product rule in combination with this, let's call it modified chain rule that we learned. I'm sure this has a good name, but all right, the derivative of 5 is just 0, and 0 times e to the power of 5x is just 0. So we're going to ignore that term completely. But then plus 5. All right, let's use our equation over here. Let's call e to the power of x as a and 5x as u. And let's take it up from there. Okay, so a to the power of u is just e to the power of 5x times the derivative of u, which is just 5, times the ln of a, which is just ln e. And as you all know, ln e is just 1. So we can just replace that with a 1. Okay, perfect. And that just gives us a 25 e to the power of 5x. Wonderful. Now let's put these together to get the final answer of 1 over x plus 25 times e to the power of 5x. And that is our solution. Thank you.